Hey guys, welcome back to the series. So we're studying chapter 2, force and motion, and we had discussed scalars and vectors in the previous lecture. So in this lecture, we will be discussing about the graphical representations of a vector, as well as more advanced topic, which is the rectangular components of vector. So as far as the graphical representation of vector is concerned, we discussed in previous lecture that a vector has both direction as well as a magnitude. So it is quite convenient to actually uh, graphically represent a vector quantity. Uh, so it's quite obvious whenever we are talking about direction. तो हमें पता है कि जब भी हम किसी डायरेक्शन की तरफ पॉइंट आउट करना चाहते हैं द मोस्ट convenient way is to represent that direction as an arrow pointing towards that direction. जब हम डायरेक्शन की बात करेंगे हम उस डायरेक्शन में आसानी से एक एरो ड्रॉ कर सकते हैं. फॉर एग्जाम्पल इफ यू आर टॉकिंग अबाउट दिस डायरेक्शन यहाँ पे एक एरो ड्रॉ करते हैं, और वी वर टॉकिंग अबाउट अपवर्ड्स डायरेक्शन तो वी विल ड्रॉ an arrow towards this direction. So obviously this is the easiest choice to represent a vector in terms of the fact कि हमें एक डायरेक्शन को रिप्रेजेंट करना है. But as far as the magnitude is concerned, we can also take care of that by just using the fact कि जिस भी डायरेक्शन में हम एरो को पॉइंट आउट कर रहे हैं उसका जो लेंथ है हम उसको उसके मैग्नीट्यूड के प्रोपोर्शनल रखें. तो the greater is the magnitude of the vector quantity that we're talking about, the larger is the length of the vector itself. So if this was, let's say, a vector whose had length like let's say this much and this direction of theta, तो इस तरह से हम एक आसानी से एक वेक्टर को रिप्रेजेंट कर सकते हैं. How we write a vector is simply by, let's say if we had a vector A, we would simply put an arrow over it. We could call this a vector A, or we could just write a bold letter A to represent a vector. Both of these conventions are actually acceptable. Anyways, so as far as the representation of a vector is concerned, it is only about drawing an arrow in the direction, whatever direction the vector is in, as well as taking care of the fact कि हमारे पास जो मैग्नीट्यूड है वो भी उसकी रिप्रेजेंट कर रहा होता है, उसके लेंथ को, या जो लेंथ है वो मैग्नीट्यूड रिप्रेजेंट कर रही है. Anyways, so we could be drawing, let's say, a vector like this. So let's say let's call this A. This A, अगर हम ये सपोज करेंगे ये जो एक यूनिट है, this is one unit. This has a magnitude of 1 as well as a direction which is, let's say, of 90 degrees. Similarly, we could draw another vector, for example, of 45 degrees. Of, again, this has a unit of, you'll have to check how much length this is to actually find इसका जो magnitude वो क्या. But anyways, the whole idea is we can represent a vector using an arrow that will actually represent the direction as well as the magnitude. The next thing that we're actually studying, extending this idea of graphical representation to another idea of rectangular components of a vector. Rectangular component. But before we really get into the rectangular components of a vector, I think it is important to first understand what do we really mean by rectangular components, or the idea of rectangular coordinates. So imagine that we have a point in space, just a point in space. It's a 2D space. So we have two dimensions and there exists this point in space. And we want to specify the location of this point. The way to do so is to give this point some coordinates. Coordinates respect to what's the horizontal position of the point and what's the vertical position of the point with respect to the origin of the point. So we say, okay, in x direction, let's say in the horizontal direction, it is on this point, whatever this point is, and vertically this has this point on y-axis. So this point actually gets an ordered pair as its coordinates, namely x and y. So this ordered pair describes what location this point is at. And these coordinates are actually known as the rectangular coordinate. We could extend this idea to 3D space as well, where we'd have z-axis as well. But for the time being, we're just concerned about 2 dimensions or 2D space. So this doesn't really matter for now. So we have rectangular components as of this point as xy. Similarly, we could extend this idea to not just a point but also a vector in a space as we had drawn earlier. So if I draw a vector here, for example, so let's say this is a vector and we call this vector vector f. Now, before I really explain what do I really mean by uh, rectangular components of this vector, because when we talked about the position of a particle, it is quite obvious. It intuition में समझ आता है कि what do we really mean by the position. But as far as a vector is concerned, इसकी जो representation, it's not a physical object, obviously, in sense this arrow is not a physical object. So it's actually quite it is worthy of understanding कि हम इसको समझे कि इस वेक्टर के कोऑर्डिनेट्स रेक्टेंगुलर कंपोनेंट से क्या मतलब है. Let's take an example to really understand कि what do the components of a force vector or any vector, what does the components mean. So for example, let's take an example of a cart. Very example that about. So we have this cart and we were actually trying to push it by applying a force in this direction. We're not applying a force directly this way, we're applying it at some tilted angle theta, and we are applying the force this way. Now the question is, what direction does the car really move in? Force is tilted obviously in this angle, so obviously you can't expect that the car will start moving in this direction, but it's obviously going to move some other way, not really this way. इसको हम इसको देखते हैं. The easiest way to deal with such a case is actually to first of all break this kind of force into the two components that it has. For example, इस वेक्टर को अगर हम देखें यहाँ पे, तो it has two mutually perpendicular directions जिससे हम इसको ब्रेक कर सकते हैं. एक upwards direction और एक rightwards direction. This some part of this force vector F has a part in rightward direction and some part is upwards. So what we say is that the part of this force F is actually pointed this way and some part of this force is actually pointed this way. Now, what direction does the cart move in really depends on whether this vertical component dominates or whether this horizontal component dominates. But currently we're just talking about whenever we're talking about a force, it actually is made up of two components that are mutually perpendicular to it. That's a common practice कि हम हमारे पास जो भी वेक्टर होगा हम उसको उसके mutually perpendicular components में break कर देते हैं. The exactly way we have done here, if we have a tilted force, we actually break it into the two force components. One is going upward and the other is going rightward. The resultant is obviously in the same direction as we talked about. We can actually talk about some other example as well. Okay, for example, we have a cart and we were pushing it from this way. हम इसको इस तरह से फोर्स लगा. फिर जो दो कंपोनेंट्स होंगे उसमें इट्स वेरी इजी टू सी कि एक कंपोनेंट लेफ्टवर्ड्स होगा और एक कंपोनेंट उसका. In this case there are two components, one is leftwards and the other is downwards. तो हमने यहाँ पे भी एक वेक्टर को उसके दो कंपोनेंट में ब्रेक कर दिया. So this is what we really mean by components of a force. Now exactly if we use this idea to really see कि हमारे पास अगर एक वेक्टर इस तरह से ड्रॉ हुआ है, हम उसके दो कंपोनेंट्स देख सकते हैं. व्हाट कंपोनेंट्स इज इट मेड अप ऑफ. उसका तरीकाकार ये होता है कि हम पहले देखें कि अलोंग द हॉरिजॉन्टल डायरेक्शन उसकी प्रोजेक्शन क्या है. this is the projection. So we what we do is we draw a vector here till this point जहाँ तक उसकी projection आ रही, and this also has a projection along the vertical axis. So we do the same in this case as well. So, yeah. So there we go. What we're doing really is we had a vector and we saw कि x axis में उसका projection क्या है, जहाँ तक projection बनता था we draw another vector. This vector is actually called as a if this is a vector a, we call this as ax, meaning कि ये x component of the vector, and this is ay, or the y component of the vector a. Exactly in this case, यहाँ पे this component is simply the fx component, this is simply the fy component, the force. So these two components ax and ay are actually called as the rectangular components of a vector. And these points in projection, these are called the rectangular coordinates, or whatever you say this. But obviously the uh, the main thing here is to know what the rectangular components really mean. That is just splitting the total vector into its mutually perpendicular components, and that's what we call as the rectangular components. All right. एक चीज जो इस केस में बताना ज़रूरी है वो ये है कि यू गाइस माइट बी अवेयर ऑफ इट ऑलरेडी, कि जब भी हम किसी चीज़ का एक्स प्रोजेक्शन देख रहे होते हैं तो उसका मतलब ये होता है कि हम उसका कॉस कंपोनेंट देख रहे हैं. इफ दिस वाज द डायरेक्शन, तो the x projection really means the cos theta of that, and the y component is really sine theta. That's a very basic trigonometric fact. The cos theta represents the horizontal projection and the sine theta is actually the vertical projection. If we were to actually find out कि ax का magnitude कितना है, that would just simply be इस total vector a का cos theta, and ay that would then simply be a sine. So these are simply the two components. So provided I do know what's the angle theta and what's the total magnitude of this vector that we have, I can actually find out how much of this vector is in the x direction and how much of it is in the y direction. That's how we actually calculate what component of the force is really dominating. For example, if we, for example, we know the total force that we are applying is 70 newtons, for example, then and I know the direction we are actually applying it in is, let's say, 45 degrees. We would then know that the component ax has a magnitude 70 times cos 45, and ay will be 70 times sin 45. So that's how we actually calculate. In this case, obviously, the both components are going to be exactly the same amount of force applied in both. Anyways, so that's what we really meant by the components of the rectangular components. The next thing we have is, इस केस में तो हमें ये पता लग गया कि if we do know the magnitude of the vector already, then we can find the components, or the other way around as well, where we find magnitude of vector from its rectangular components. So it's the other way around, where we do know the rectangular components, but we're not sure of what the total magnitude really is. So उस case में भी we can actually find out what is the total magnitude of the original vector. Now, to find it, we will be using Pythagoras theorem. What we really do is, we've already talked about, let's say we had a vector like this, then the component in the x direction has something like this, whereas the other was vertically this way. Now this is a right angle triangle, right? So we can easily use uh, the Pythagoras theorem. What we really do in Pythagoras theorem, we already know. Okay, we to find the resultant, this we use square equals a square plus b. We can easily name these. For example, this origin is O. This point is E. This is B. Then we already know. Okay, this resultant is actually equals to OP squared equals to, let's call this as A, this as B, and this is OB squared plus BP squared. Now this OP is nothing but our original vector itself. Let's call this A. Then this is actually equals to this AX squared. So we take the square root here, and that is going to make it AX squared plus Y squared. And this is actually the magnitude of the vector A itself, AX. Notice I'm not putting an arrow over it or making it bold because this is just the magnitude of the vector. This is not the whole vector. This is just the part of the fact how strong the or how large the length is. This is just the magnitude itself. When it combines with the direction, then we really call it a full vector. This is just the magnitude. So the magnitude is simply the squares of the two components added together with the square root of it. Now we can also find what direction is the vector really in case we already know okay the components ax and ay वो हमारे पास क्या है. Again, to use a geometrical fact, you guys already be aware. A vertical और horizontal जो projections होती हैं उनकी जो ratio होती है, that's what makes tan theta, right? We already know tan theta is equals to sin theta over cos theta. And the whole idea behind this fact is कि जब हमने यहाँ पे बात की थी projections की, ये वाली projections की हमने बात की थी, तो हमने यहाँ पे देखा था कि हमारे पास दो तरह की projections थी. One was the horizontal projection and one was the vertical projection. How much projection is vertical and how much is horizontal, we look into a ratio of that, and that ratio is what makes tan theta. So we can actually then find this angle theta once we know this projection. In our case, sin theta cos theta की जरूरत नहीं है. We already know we have the vertical projection as ay and the horizontal projection as ax. Tan theta in this case is going to be ay over ax because we are looking at vertical projection vector over a horizontal. So tan theta equals to ay over ax. We already know okay, tan is an operation. So to find just the theta, we can take tan to this side. Tan since tan is operation, वो उस तरफ जाएगा तो वो inverse हो जाएगा. So this is tan inverse ay. So that's how if we do know the two components, the two rectangular components of a vector, we can actually find out the direction as well as the magnitude. So we can just write these results as a conclusion. What we really have is to find the magnitude, we have squaring the two components and adding them. And the other thing that the direction, we have tan inverse ay over a. All right. So that's all the information that we need regarding to the fact okay, what a vector is really made up of. It has two quantities. One is the magnitude, the other is the direction. We already know okay, this is the magnitude, this is the direction. So we can find out these two quantities very simply using these formulas. Later on जब हम इसमें problem solving करेंगे, we will see कि oftentimes we do know the components of a force, but we don't really understand कि वो total force कितनी थी. So in that case, we will be using these formulas, or we do know the components, but we want to find what the angle really was. So we can easily use the information from the components to find the angle or the magnitude. Together, these two informations will make up what we call as a vector. For example, uh, let's say this turns out to be 5 and this theta turns out to be 30 degrees. Then we can say the vector really is a 50 in some direction of 30 degrees. So we can actually, so this quantity is now a vector because it has both the magnitude as well as the direction. Anyways, in the next video series, video lecture, sorry, we will look at an example of the vectors with components and angles in intersection. All right. So thank you so much. See you guys in the next video.